Hello and welcome to another Micrographics webinar, Fusion 360. Today we're going to be looking within Fusion 360 at basics of creating an assembly and some of the tools that are available to assist with creating the assembly and visualizing relationships between components and motion within the assembly. So we're going to jump right in and go to our agenda. We'll start off with a introduction. From the introduction, we will then move on to looking at the differences between, or looking at multi-body design, how multi-body design works in Fusion 360. From there, we'll move to looking at the distributed designs process, how distributed designs works and how that compares to multi-body design. When we've looked at that, we'll have a look at assembly tools and what tools are available within Fusion 360 to assist in the assembly process. Then we'll close off at the end with a summary and we'll open up to any questions from those in the live chat, and we'll answer any of the questions that come up in the live chat. Feel free at any point to drop a message in the chat, and I'll keep an eye on the chat and respond to those as and when I can. And if you have any questions, you can put them up there in the chat as well. If you're not watching this live, you're watching it after the fact, feel free to drop a comment on the video or contact us with the on the contact details on the first or last slides. So we'll move on to the introduction. Firstly, myself, my name's Carl van Rooyen. I'm an application engineer with Micrographics. I specialize in the manufacturing side of the Autodesk products, mainly with Inventor, Fusion 360, and Vault. And as we said today, we're going to be focusing on Fusion 360, so I'll be pulling on that knowledge. And our introduction here for the assemblies on Fusion 360, basically, if we're looking at designing something that needs to be made up of multiple components, we need to be able to design out each of those components and be able to identify them separately within an assembly, whether that is a basic assembly like we've got the caster wheel here with a central hub, the outer urethane wheel material itself, there's a cover on it, maybe an axle and some bearings, and we might only have 4 or 5 different components within that small assembly, but we still need to be able to identify those individual components and see the various properties, whether it's material properties or appearances with those. And we can go up to more complex designs. Here I've got one of the Fusion 360 data sets in this motorbike, and there we've got all the various components that make up that motorbike, and there's quite a lot of detail involved in creating that assembly. So Fusion 360 can cater for the most basic of assemblies, 2, 3, 4 components, all the way up to more complex designs, motorbikes, electric wheelchairs. Another example that I've got is a router, CNC router, and so it caters for those various levels of complexity that's required. And it does this in a couple of different ways. Fusion 360 allows you to achieve this end goal of creating an assembly in sort of 2 main fashions or 2 main ways. The first is multi-body design, and we'll go on to the next couple of slides which cover what multi-body design is. But in a nutshell, it allows you to have one design file and have all of your components designed within that single design file. The next option is the distributed design, or the other option is distributed design. This allows for multiple designs to be created and then brought together into one design file. So you may have multiple design files stored within your data panel, and they can then be inserted into a central design where they are all then connected together. And one of the tools we're going to look at that can assist within this process, one of the assembly tools we'll be looking at, is the derive tool. Apart from looking at joints and motion links and some of the other options, we'll have a look at what derive can help you do within the design environment as well. So having a look, a little bit of a deeper dive into multi-body design. As I mentioned as part of that intro, all the components are in one design file. So looking at this motorbike here on the right hand side, if we look at the browser there, we can see that within the browser we've got various sub-assemblies like the front suspension, the fairings, we've got a part, the roller chain, more sub-assemblies going all the way down, rear braking system and so on. So all of these components have been designed in place within this assembly. So we have one single design file, and all of these components either started off as bodies, which were then converted to components, or they were components that were created empty and then activated and information then designed inside of that, extrusions, revolves, all the sorts of features that would build up a component. So all of these parts are designed in place, and what this means is that they share a few things. They share the same coordinate system. They will all have the same origin. So if you had to look at the front wheel and the back wheel, they would typically then share a origin point. And so when having to assemble these together, if we had to pull out these components and create a different assembly, they would all line up to that same origin. This also allows us to create a single parameters table. We'll have one parameters table with all the parameters listed in that table for the entire design. We can then have favorites within that. Could be things like wheelbase, handlebar width, tire diameter, and we can have those parameters drive the different components. The nice thing with this is that, let's say we change the rim diameter, the same parameter can be used to adjust the rim diameter as well as the tire diameter. So you're changing one value and it will have a knock-on effect with various other components within this design. If we go further into that, if we change the rim diameter, the spokes are going to have to update as well. And then lastly, we also have features that can be shared across different components. An example here would be where you may have 2 or 3 components that are layered together to create almost like a sandwich, and you need to drill a hole through all 3, and that hole needs to line up through all 3 components. You can create a feature and select those 3 components to then make that hole through those components to ensure that there is correct alignment. So for something like this motorbike, we could have an extrude that creates a hole through the frame and the swing arm, so that we have that pivot point for the swing arm and it lines up perfectly between the 2 components. In this case here, if we want to edit specific components, you would typically activate the component. So let's see the roller chain there in the browser, roller chain V1. You could activate that component and you would then be editing within that component, and anything you do for that component will be captured in its history. Doing this multi-body components, every component you activate will have its own timeline, its own history at the bottom of the screen, and any features you add while that component is active will be added to that timeline. Same would be said for sub-assemblies. You can activate sub-assemblies or activate components within sub-assemblies, and those features would then be listed with, or would be added within the active component or sub-assembly as you add more features to the timeline. At the top level, in this case here, the dirt bike V1, that top level assembly is active. That timeline for that component, or for all of the components and sub-assemblies, would be exposed, and you'd see the entire timeline for that design within the timeline in Fusion 360. So you would be able to scroll through the entire timeline for that entire assembly when the top level is active. But as mentioned, when you start to activate sub-assemblies or components, you would then only see the features related to those components. So multi-body design, you've got all of the files within one, or you've got all the components within one design file. The drawback to this is that only one person can edit that file at a time. If I have that dirt bike assembly open, I'm the only person that can work on that. If somebody else needs to work on it, maybe they're doing design work on the covers for the exhausts, but I'm doing design work on the front fairing, I would have to click save and exit, and then they would be able to open the file and do the work that they need to do. So when it comes to working in teams, that does have a drawback to working with the multi-body design process. So this is where distributed designs has a leg up on multi-body. And the way distributed designs works is it allows you to use multiple files that are then inserted into a main design. So in this case here, this example, we have a tripod. The design file would be a file called tripod in the data panel, and the components for this tripod are then linked in or inserted into that tripod design. So we have our main assembly file, but we have all of the subcomponents as individual design files as well in the data panel. These are then inserted into the main design and they are assembled into place. Depending on their position when they come in, if they're in the correct position already, you could use as-built joints. We'll talk about joints later. Otherwise, you can use a standard joint to connect the components together. But what we see within the browser is that we have a link back to the external file. So the tripod top subassembly and the leg subassembly that we have here. We see the links there in that middle, with that left-hand image. Got the link that's highlighted with the red box around. That shows us that those components are linked from an external file. And that's the biggest difference. If somebody's working with the tripod, somebody else could open up the leg subassembly and work with the leg subassembly. So this allows multiple designers to work on the individual files. That leg subassembly is also made up of about 5 separate components that are also external components. So if somebody wants to make a change to the rubber foot for that leg, they could open that file on its own and start making changes and start working on that design. If they save that design, whoever has any of the sub-assemblies or main assembly open, they would also be alerted that there is a design change. There has been a change in this this year with milestones. I'm not going to talk much about the milestones at this webinar, but if there is a milestone for that design, any changes made to those external files will not push through as updates unless a new milestone is created. So this allows multiple designers to work, and it also allows you to insert reusable components, things like standard off-the-shelf parts that you may have downloaded and put to one side in Fusion in a in a buyouts type folder. It could be nuts, bolts, washers. In this case, for the camera, it could be hardware that is used to mount cameras too. So your standard threaded inserts for camera mounts, or the actual nut itself that would be able to be pulled into the design. If we look at the motorbike in the previous example, any off-the-shelf components that would be used on the design of the motorbike, brake discs, brake calipers, those sorts of things. And so you can have that one external file, but it can be linked into multiple assemblies. Now, when it comes to making changes, as I mentioned, you can open those files separately and design and work with them in a separate document, or you can do what's called edit in place. You would be able to edit that part in relation to the assembly. So the tripod top or the leg sub-assemblies, you'd be able to edit that sub-assembly in relation to the main assembly and make changes and design decisions on that sub-assembly while you're still able to see the main assembly. This also allows you to pull information from the main assembly into that either sub-assembly or component that you are editing in place. So that also helps with the design process, pulling information from one part of the assembly into another part of the assembly. Okay, so we're going to go into a demo now. We'll have a quick demo on the two different setups. We've got the essentially the design in place, and we've got the distributed design. So I'll start here with the design in place. I just want to have a look quickly. So here I've got a wheel. It's got two bodies in here, and we want to potentially design something, maybe a bearing or a shaft through the center of this. And so with the design in place aspect of, or the multi-body workflow for assemblies, we would go here to the assemble panel, and we have the option to create a new component. And by creating that new component, we can choose for that component to either be external, which would be our distributed design option, or we can go internal, which means that we are creating a body internally inside of this wheel design. So I'm going to keep that there. I'm going to call this, let's say, shaft, and we'll hit OK. And we'll see here now that on the left-hand side, we have a new component, and that component is called shaft. And we can design the shaft now in relation to the other bodies that are inside of this design. So just do something very simple, create a sketch through the center of the part, and I'm going to go ahead and project geometry here on that inner diameter. And just going to use that projected geometry just to create something very basic here, just a rectangle. We'll go ahead and constrain that rectangle to that geometry that was projected. And just add another dimension here just to set how far out that is going to be protruding from the design. So what I'm going to do here is then just revolve half of that. Probably would have been easier ways to do it, but just going ahead there and putting in a design. I'm just going to add some more details, so just a little chamfer on either side. And we can see at the bottom here, we've got the timeline for this component. So the shaft is a sketch, a revolve, and the chamfer. I'm going to add a hole through here just for the sake of adding another feature. Let's do a through hole. And we then have that feature as well. So going back and activating the main assembly now, we'll see that at the top it says, it shows that this is an assembly. We can activate that. We then have the two different bodies. Body one has actually the hub, and the second body one with the one in the brackets is the wheel. We then have the shaft as well. And you would continue that process. These two bodies have been brought in with the derive function. We'll talk about that later on in the presentation. But we see at assembly level, if we activate the assembly, we've got the derive feature, we've got the create new component feature, and then we have the features for the new component, and we'll see they are colorized for that component. Once again, if we activate that component, we can continue to work inside of that component. So I'm going to go ahead and add a chamfer on the inside, and that is added. We'll do this one more time, just very quickly. Come back to the main assembly. I'm going to create a new sketch. I'm going to just be a little bit more clever about this one. I'm going to create it in a side view, and this allows me to then just project in that internal diameter and extrude that symmetrically. A lot quicker and easier. Let's go, whole length is, let's say, 50. And you'll see here I've made the mistake of not creating the new component first. I created a sketch, which is now actually at the top level. So the assembly was active. Not necessarily a mistake, just a different way of doing it. With the assembly active, I created the sketch and then an extrusion. So we can see in the timeline, the sketch and the extrusion. That's created a body in the assembly. There's no problem here with the body. With this, we can rename it, and that body can also be converted. So you can right click on that body and choose create component from bodies. That will convert that from a body to a component. So we now see the component there. The only downside to this is once you have converted a body to a component and you activate the component, you will see that there is no history in the timeline. There's no features in the timeline for how that body was created, how that pin was created. So that those features are at assembly level there to show how that pin was created. Okay, so that would be your multi-body design, and we can see there we can have multiple bodies in the design which we can promote up into components, or we can create components at the assemble tab, new component, and then design within that component. The other method for distributed design would allow you to take a empty design. It has to be saved with a file name so that Fusion can link the designs, and you would take components that are already designed up. So I'm going to grab these tutorial components from Fusion. There's a base here. I want to insert that base. You can either drag and drop, or you can right click and choose to insert into current design. And that will then insert that file into the design, and you have the options to move that component around in the design, or you can click OK, and that places it in. One of the biggest things here is that at least one of the components that you place in should be grounded so that it doesn't move around, and that creates a fixed base to be able to join everything else to. And then from there you can take the other components and you can insert them. I'm going to take this one and just drag it and drop it in, and that'll be added to the design. Click OK, and we now have components that are added to the design, which can then be joined together using the joints command. So I'm going to go ahead and just grab one more, drag and drop that in, and I'm going to move this out the way. And that would be how you bring in your components for the distributed design. We're going to go back to the presentation. We'll have a look at some of the joint or some of the assembly tools, and we can come back to this and look at how the joints work on this. So let me head back into the presentation, and we're going to look at assembly tools. So we already went to the assemble panel and had a look at the new component for that multi-body design process. We can create new components We do have the option with the new components to create it internally or externally to the file, depending if you want to follow the multi-body or distributed design approach. What we need to look at now is the joints within this, and we now have three different options with regards to joints. Joints and as-built joints have been around for a long time. Duplicate with joints is something that's reasonably new, which is actually quite a nice option that has come in to Fusion. So joints is typically something that you're going to be using mostly with your distributed design. So if I just Alt tab back here to Fusion, we can see that I've got some components that are floating around here in the assembly that need to be connected in the correct place. So the joint option here is what would be used to move that component or to align the components according to their relationship that they should have with each other. So just as a quick demo here, I'm going to go to the joint tab. I'm going to select the central point of the cylinder on the shaft and the central point of the cylinder here on the base where the shaft aligns, and that will align those two components. Now, part of the joint creation is to choose the motion that you want for that joint. In this case, we could go with either a cylindrical or a slider. I see that the hole here is already horizontal. I'm happy with that alignment. So I should be good to go with a slider option here, which will allow that shaft to slide back and forth. If I wanted the pin to be able to rotate, or the hole for the pin to rotate, we could go with something like the cylindrical, which allows it to rotate and slide. And so that there allows you to add joints to a model and limit the motion of the components within the model. Let's do one more joint here just for the sake of putting that joint in. I'm going to go here, that central point there to the central point of that cylinder, and in this case just going to quickly throw in a revolute joint that allows rotation there. So the joints option allows you to bring two components together and connect them with a specific relationship. As-built joints are slightly different. If you have components that are already in the correct orientation, and I'm going to go back to the this wheel body that I had here, we'll see that I've designed these components in place. However, they are not connected, so we can actually grab and move these components. And so these components that are movable need to be connected together, and this is where we can use the as-built joint. The as-built joint option looks at or maintains the current position between the two components, but allows you to add a specific type of motion that those components will have. So I'm going to keep these rigidly connected. If I click OK, these two components, the shaft and the pin, are now rigidly connected together. If I grab one of them and move just one of them, they will move together as a unit. Can repeat the process of the as-built joint between the wheel bodies and the shaft. And if I choose revolute here, that wheel body will rotate around a selected center. And so we have this rotation available within the wheel. So the as-built joint keeps the components where they are, but you can then select how they should move relative to each other and their either axis or point of movement, what they term your, let me go back in there and edit this one. What they term here the snap point. That is the point at which the motion that you choose is going to act around or along. And then duplicate with joints. This just allows you to copy a component and keep the joint attached to that component. In the case of something like a bolt into a plate, if you copy or duplicate the bolt, it will duplicate the joint that is connecting that bolt to the plate. So it allows you to easily duplicate the bolt and then place it down or join it to another hole in the plate. So if you have 10 bolts, you can duplicate the first bolt that's already connected and connect it to the other holes. I don't have a demo for this one, but that is a nice option. This is reasonably new within Fusion as well. Came out this year in one of the updates. Then from a motion perspective, I'm going to jump back into Fusion on this as well, but on the right hand side here, we can see we've got 4 different options within the assembly drop-down that allow you to adjust motion. So we can see we've got the ability to drive joints. Essentially, when you drive a joint, you are going to just be setting a new position for the joint. So if I go here into this example and we go to joints, I can take any of these joints that are movable, let's say this revolute joint, drive joint, and then set a new position for it. So rotation is currently minus 19.2, to change it to minus 40, and you can see that that joint is moving out to a negative 40 angle. So the joint is here where the tripod leg joins to the head of the tripod. So if I go here with a minus 20, that leg is then moving. And so that will just drive that joint to a new position, a new location within the design. So we've got the ability to drive a joint to a new location. The motion link allows you to link motion between joints. So in this case, what I actually have here is 2 motion links set up. And essentially what this does is when one of the legs moves, that joint that we were driving, when that joint is moved, it is linked to the other joint on the next leg, and that's also linked to the joint for the third leg. So when we adjust the first leg, the other 2 legs adjust accordingly. And that motion link is simple to set up. When you go to the assemble drop down, you've got the motion link option there. All you need to do is select the 2 joints that you want to link together. So in this case, it was, let's say, Revolute 2 and Revolute 3. And in this case, it's telling me that already exists. And we can see here that we are able to set, it's 2 rotation joints that we chose, and we're able to set the relationship. If we change the angle of the first one by 360, the angle on the second must change by a specified amount. So we could actually say 180, and we'll see that when one of those move, the other one wouldn't move as much. And I think I've got an issue here with the, I'll just change the first one here rather. And so we get half of that motion. So you can see the one spinning twice as fast as the other. This works well for things like drive screws, where you have a screw with the pitch of, let's say, 10 millimeters. For one rotation of that screw, you're driving a component by 10 millimeters. So something like a vise or a clamp. You can turn the handle of the vise and the vise is going to close. So you can create those motion links. Contact sets. Contact sets allow components to know that they can come into contact with each other. So for this tripod, if we move these legs closer together, we'll see that the feet will actually come into contact with each other. These are set up as a contact set. So they will not actually pass through each other. They will stop and prevent each other from moving any closer. So as soon as these components come into contact, they basically form a physical barrier for each other, and they will essentially come into contact and stop in the center there. And then lastly, another assembly option here that I would like to cover is the ability to create motion studies. Now, with a motion study, the idea here is that you are able to select joints. I've got one pre-created here because this does take a little bit of fiddling around. You're able to take joints. I've got 3 joints selected here. and you can graph essentially a time versus position or step versus position graph out here. So the first joint, the red one, at step 0, we're at 0, but then at step 60, we move to a value of 50. So that's the position. And the other three graphs have just staggered the position. And what this is doing is it's moving the slider from 0 to 50 millimeters. And so if we go and play this, I'm just going to put this on a back and forth loop and hit play. This will essentially extend and retract those three joints. Rotate the model around. Cancel this. If I spread the legs out, we'll see this a little bit easier. Edit that motion study. And I'm just going to play this on a loop. And so you'll see there the legs, or those sliding joints, are being moved according to the graph that's created. So this allows you to preview steps within a mechanism. If you have an assembly where there are moving components that move in relation to each other or at specific times, then those components can be moved using this motion study option. So we can see here, in this case, basically just extending the legs out one after the other with a slight delay. And we do have a speed dial here that we can dial back to let that play a bit slower. We can see what's going on there. So each leg is extending outwards and then back in with a bit of a delay between each one. So that is your motion study. The ability here on the assemble drop down to create a motion study. As mentioned, you may have a machine with pneumatics or hydraulics that activate at different points in time. You can then take the graph, or you can take the joints and you can drive the motion of those joints at specific times in that graph. And you'll see all of these as you create them, they do come up in the browser. We'll see contact sets. I've got the contact sets there in the browser, the motion study entry in the browser, and you can create more than one motion study as well. And then the motion links, you can see motion links here as well. You can create various motion links there as well. So those are a couple of the assembly tools that are available. Kind of done that quick demo there already on those as we're talking about them. And then the next slide we've got here with assembly tools covers the editing in place of components from a distributed design. So here we have once again that camera tripod, and I spoke earlier about being able to edit in place and make changes to one of the sub-assemblies. So here we've got that leg sub-assembly that is created, or that was being edited, and you can see that the rest of the assembly remains visible. We can see the rest of that assembly in context with the leg of the tripod. Now, when you do this, this will create two context menus within the browser. It creates an assembly context and what we call a local context. Now, I've got the three images here. On the left hand side is the tripod with the leg subassembly being edited in place in relation to the assembly. Notice the origin position here relative to the head of the assembly. So the origin is not located at the foot of the tripod leg or at the top of the tripod leg. It is out in space, away from the component. But if we look at the local context, essentially if we open up that tripod leg as its own file, we will see that it was designed with the origin based at the bottom of the outer tube of the leg. So we've got the origin there. So when we open this file up, we will have the local context of how that subassembly was designed. So it was designed with the origin at the base of the outer tube. But we can also switch to see how it is positioned in context with the assembly. So within that design file itself, and we'll do a demo on this to show this, we will see that we're able to switch between local context and assembly context to see how this component shifts to then be positioned in the assembly. Kind of think of it being moved away from its own origin to be able to align it with the component in the assembly. And that's what would have happened during the use of the joint tool. The joint tool has moved this part away from its origin and positioned it into the head of the tripod. Okay, so let's actually go back into Fusion and have a look at that. So here we are actually in that assembly already. And so if we go and we go to one of these legs to edit it, you can actually see what happens is when I move my cursor over that leg, it's highlighting the leg on the tripod, but you'll also notice it's highlighting a tube or a leg that's not aligned with the assembly in any way that makes sense. And that is actually the two different contexts that are being sort of pre-highlighted. Now, to edit in place, you would go to the linked in component and you would select the edit in place little pencil. That will activate the component. If you have moved something, you would choose to revert or capture position. If you have moved a component within the assembly, so I'm going to revert position back to the original sort of position where the joints were created. And there'll be a little message dialog box that comes up and lets you know about the associative edit in place, which will create the assembly context within the subassembly itself or component. So I'll click OK. And we can see here that we are now able to edit and make changes to the subassembly in relation to the main assembly. It may be that we need to remove some material from the components to allow for clearances. We may need to make some changes where these 3 feet meet. You may want to create flat spots so that they nest nicely together when closed. We may need to ensure that there's room for a shaft up the middle, so we might want to cut a semicircle out of that foot. So various things that we could do now in the assembly context to be able to modify this leg. Now we'll see here on the left hand side within the browser we have the assembly context, and we can expand that out with the assembly context folder, and we can see that we've got context 1. It's the current context within this assembly. We can activate that context and we'll see pretty much what we have or what we had, or we can go and activate the local context and we see the part without the assembly. And so here we should see we have the origin at the base of the part. This is as it was designed as a subassembly, and we can make changes to this design without seeing the context of the assembly. But if we want to be able to see it, how it fits in the assembly, we can go to the assembly context and activate the assembly context. And we can see how it shifts away from its origin to how it's positioned in the assembly. So depending on what you want to achieve, you can adjust which context you're going to be editing that component in. Okay, so there we're able to switch between those contexts. We can also, lastly here, we can also open that file on its own. And even with that file open in a separate window, we are able to switch between the local context, which is currently active, or the assembly context, and it actually shows us what component it is joined to in the assembly. So we can see how it connects to the components in the assembly. So even with that file open, we can see how it is connected, related in, or connected in the assembly. Okay, we'll move on from the edit in place to the derive. Now, this one here, I'm not going to go through step-by-step demo on this, but just going to show how this can help. Essentially, what derive allows you to do is it allows you to take information from one design and push it into another design using just the straight derive option. Or if you use the insert derive, it allows you to pull information from a design into another design. So what this does is it allows you to take either bodies, sketches, planes, construction geometry, solids, components, parameters. It allows you to take any of those features from one design and push it or pull it into another design. It allows you to include it in another design. So as an example here in Fusion, I have this this wheel. This is my base design. We've got the hub and the wheel, the tread, and this is drawn using parameters. We've got the main assembly and the two components. And from here, what we can do is we can say create derive, and it's going to push information from this design into a new design or into an existing design. And you can choose to either derive components or objects. Now I've pre-baked these already, so we actually have here a wheel with some components designed around it using the multi-body design approach, also some components inserted from McMaster Car. In this case, what I did here was I did the derive where it pushes from the design. So we had the wheel open, it said create derive, and pushed the components into the new design. The one thing I did notice about this is that the hub and the wheel, they do show in the new design, but there is no link or anything showing here that it was pushed from this wheel. However, if we do go to the wheel here and we change parameters, let's say we change the hub, the width of the wheel from 25 up or down. Let me just go ahead and confirm here. We can go to this one and measure. We'll see that we're at 25. We can go in, we can change the parameter here to 30. The model in the background did update. We can double check. It's now 30 wide. And when we save this, because this has been derived into another design, when we go to that design, we can then update. We'll see a little warning here. Whenever components are out of date, we get that warning. We can click on that to update the component, and we'll see this design update to the new width. So there we go. The cover itself updated, the width of the wheel updated as well. So there it's 30 wide, and I could go ahead and put in a ridiculous number here just to make it more obvious. Let's go from 30, let's double it up to 60. There it's nice and wide, more heavy duty. Save the design. Come across here, update, and we'll get that update here as well. So you can have a component derived in and work with that component, have somebody else separately working with that component and you working with something else that links to it, and have those designs update. Alternatively, you can do what's called a insert derive. What an insert derive does is it pulls information. So we can say, okay, we want to insert derive, and we're going to choose a component to derive from. So here I can go and grab from the wheel and choose from that wheel what we want to pull. So here it's busy loading. It's opened up the wheel, and we can say, okay, we want to derive in maybe just the hub. We can design a new tread pattern around the hub. In this case here, you'll see that it brings it in as a body. Alternatively, I can click on the component itself and it'll bring that component in with its body. So you can choose from the browser on the left-hand side what information you want to pull from that design. Now I've got this one here, here, it's already done. In this case here, I pulled the body for the wheel and the hub through. So there's the hub, there's the wheel into this design. So once again, this design is also linked to that previous design or that previous wheel. So it's also out of date. If I update this, we should see this update to that 60 width. There we go. And so that also works on that update. What I do like about this method is that it shows here that it's an insert derive. So you are aware that this geometry came from or is linked to another component. So the derive allowing you to either push or pull features from one design into another. These features include components, bodies, sketches, construction geometry, flat patterns, and parameters. Okay, I've been bouncing back and forth for the demo, so we're not going to run a separate demo for this. It's going to let me just quickly jump now to the last slide before our summary, which is a bit of a bonus, is mixed design. Now I've got two examples, two data set examples here that we'll go through, but essentially a mixed design allows you to work mixed between multi-body and distributed design. Whether you start off with a distributed design and then you break links to components, or you start designing bodies internally inside that distributed design, or you start with a multi-body and then bring in external files. Either way, you can work in this mixed environment. This router data set that we've got here that Autodesk provide shows us a couple of components or sub-assemblies that are linked in. So we can see there's the assembly for the base frame that's linked in, but we also have some components like the gantry frame or the Z-axis assembly that are built internally inside the design. So there's no link, that you have to have the router assembly open to be able to edit the gantry frame or the Z-axis assembly for this design. So you have the freedom to design components in place or insert files into the current design. One thing you can do is, let's say the updated gantry, we want to for some reason break the link to that external file. That is possible as well. This allows you to essentially insert a component. Let's say I'm going to use the pedestal actually as an example. It allows you to insert a pedestal. It might be a standard component that is used across multiple machines. You can insert that, but then break the link to the pedestal to then modify it and customize it for this specific machine. And so if I go back to Fusion here and we go to that router, here we have that setup, and we can see there is the pedestal. It is linked to an external file. If I actually go here to the router, you'll see the distributed design. There's a whole lot of different files that are linked into this assembly, and one of those will be the pedestal. There it is. So it's linked to that pedestal. We can right click, open it separately, modify it, or we can choose to break link. And break link will sever that link to that external design, and it will then create all the features and information that is stored within that external design into an internal component inside of this assembly. Asking if it wants to break link here for the subcomponents, I'm going to say no, let's just do it with the main component only. So the pedestal main assembly link will be broken. I can modify this pedestal as needed, but you'll see there are certain things like the screen mount that is worth having as a linked part because that's just a buyout, the monitor as well, and the keyboard. But the rest of the components, the sheet metal components, they are now internal and they can be modified as required within this design. So I can actually activate the cabinet body, and make design changes as needed on that cabinet body. So that's just a little bonus tool there. On the dirt bike, we can see this as far as we can see. If we look at all of the components, this looks like a complete multi-body design. So if we look at the front suspension origin, that origin is here towards the rear, almost at the pivot point for the swing arm. If we look at the fairings, its origin is also at that same point. And so we'll see these all share the same origin. But I do know with this example, the was it the front wheel, that may have been an external design. If we, no, sorry, it wasn't that one. Rear wheel, let's check the rear wheel. The back wheel itself, the actual wheel, its origin is at the center. So that may have been something that was inserted into the back wheel assembly and then the link broken. So this here, we do have some origins that are shifted. So these components that have those shifted origins may have been inserted. Could have been a file that was downloaded and inserted, but then the link broken back to that link broken to that original. Okay. So this one here with those basically the multi-body design, and some of these components may have been external where the link was then broken. But if we look inside of Fusion as this sits, it is a single file now, and that's also easier to send to somebody. You just send them that single file and they can open it up and work with it. Where with distributed design, you have all the various components. Okay. Starting to run towards the end of the hour here, so I'm going to quickly go through the summary and open up for any questions. I haven't seen anything come through on the live chat. So just on the summary, Fusion 360 is very flexible when it comes to assembly design. We looked at the ability to work with multi-body assemblies versus the distributed assemblies, those two different ways in which we can work, and mixing the two and doing what I like to term a mixed assembly, where you have internal and external components. Also allows us to derive, where we can either push or pull information from one design into another, where the designs have relationships to each other. They have to kind of fit together in a specific way. The derive function allows you to bring that information or share information across designs. And this allows, this flexibility allows Fusion to cater for individuals or large teams, because we have that ability to do, for individuals to do multi-body design, and for larger teams where multiple people need to be working at the same time, we can have that distributed design approach. And once again, some of those assembly tools there allow us to preview that assembly motion, where we looked at the joints, the motion links, the motion studies, where we can preview motion within an assembly. But the main takeaways here is the flexibility in the assembly design process that we have within Fusion 360. And with that, I'm going to open up for Q&A. I have been keeping an eye on the live chat. I have not seen anything come through on the live chat. So I'll just give a minute or two. I don't see any participants in the participant list, but just in case for some reason there's no one showing, just give a minute and review or see if anything comes through on the Q&A on the live chat, and we'll then close off. Okay, we haven't had any questions come through, so I'm going to close off. I'd like to say thank you for watching. If you've watched this after the live broadcast, thank you for having a for watching the presentation. I hope you had some good takeaways from this basic overview of the assembly environment. Once again, my name is Carl van Rooyen, application engineer with Micrographics. My email address is up there on screen. And thank you for your support. If you would like to contact Micrographics, we've got up there on the screen now our website, mgfx.co.za, and for more information you could contact info@mgfx.co.za. Thank you for watching. Please like and subscribe to our YouTube channel if you enjoyed this. We do have a lot more webinars and short videos up on the channel as well. And don't forget to click for notifications for upcoming webinars, live demonstrations, and other short videos that we may post up onto our platform. Thank you very much, and goodbye.